So if you think a cyber attack looks like a hacker furiously typing green code in a dark hoodie, it is officially time to update that mental image.
Right. Yeah, that's pure Hollywood at this point.
Exactly. Because today, that hacker isn't typing at all. I mean, they might not even be at a keyboard.
Yeah.
We are stepping into a reality where the attacks are practically invisible and the adversary, it isn't a human being. It's a machine.
It really is. It's machine versus machine now.
Yeah. And welcome to this deep dive. Today, our mission is to explore a truly eye-opening 2026 research paper. It's by independent cybersecurity researcher Idris iclek.
Yes, titled Deterring the Invisible.
Right, Deterring the Invisible. And it's part of the Frontiers in Autonomous Cyber Defense series. We're going to unpack how AI has just fundamentally changed how we're attacked, and I guess more importantly, how we have to defend ourselves now.
Which is a complete paradigm shift, really.
It is. And honestly, whether you are an IP director prepping for a board meeting, or, a startup founder, or just someone trying to understand why your company's security policies are suddenly so aggressive, this matters to you.
Oh, absolutely. It affects everyone.
Because we are talking about a velocity crisis, where your company's most sensitive data can be stolen in less time than it takes you to read a smartphone notification.
What's fascinating here is that the era of what we used to call fixed logic cybercrime is completely dead.
Okay, dead as in, like, obsolete.
Completely obsolete. I mean, the adversaries you're facing today are no longer following a rigid pre-written script. They are reasoning.
Wow, reasoning.
Yeah, they're making complex decisions in real time, adapting to your specific network layout right on the fly. It is this fundamental, really terrifying shift from simple automation to genuine, goal-oriented autonomy.
Okay, let's unpack this velocity crisis.
Yeah.
Because to really grasp what's happening, I think we need to understand exactly why our old defenses are failing so spectacularly.
Right, and it really all comes down to the sheer physics of speed.
Yeah, looking at the historical data mapping from the 2026 CrowdStrike Global Threat Report, the drop-off in our reaction time is just staggering.
It's a cliff. It really is.
Back in 2023, the average breakout time, which, just as a reminder, is that window between a hacker getting a foothold, like phishing an employee, and then moving laterally to their actual target, that was 84 minutes.
Which gave defenders at least a chance to breathe,
Right, but by 2025 and into early 2026, that average plummeted to 29 minutes.
Yeah. And as concerning as that averages only tell part of the story here.
What do you mean?
Well, iclek's research documents a record-shattering breach from last year that serves as the true wake-up call for the industry. An autonomous adversary pivoted from a single, low-level entry point to full enterprise exposure for exactly 27 seconds.
Wait, 27 seconds.
27 seconds.
I mean, think about the mechanics of traditional security.
Yeah.
It's essentially like a bouncer checking IDs at the door of a club.
Yeah.
Right? You're looking for known troublemakers, known signatures.
Exactly. The bouncer has a list.
But if an attack happens in 27 seconds, it's less like someone teleporting and more like a shapeshifter who walks up to the bouncer, reads his mind to see exactly what a perfect, valid ID needs to look like tonight, and just prints one on the spot.
That shapeshifter analogy is incredibly accurate, actually.
Because if your defense requires a human analyst to get an alert, read it, sip their coffee, and click approve to block a process, you've already lost. The data is gone before the IT support ticket even opens.
It's long gone. And to understand how it happens so fast, we really have to look at the underlying architecture of the malware itself. We've moved from deterministic adversaries to stochastic adversaries.
Okay, stochastic. Break that down for us.
So deterministic means the malware operates on a rigid decision tree. It's a set of pre-coded of-thin rules.
Like if it sees a firewall, then try this password.
Right. If it sees a specific brand of antivirus, then it tries a specific pre-written exploit. But the new AI-native malware operates on a neural path. iclek highlights a variant called lamehug.
Lamehug. I love the names they give these things.
Oh, always. So lamehug was attributed to the Fancy Bear Group in 2025, and it completely abandons the IFIN model.
So if it isn't using a pre-coded decision tree, how does a piece of malware like lamehug actually know what to do when it lands on my specific laptop? I mean, it can't just guess, right?
It doesn't guess, it observes. When Langhug lands on a machine, it quietly catalogs your specific defensive tools, your operating system version, and your network architecture.
Just doing recon.
Exactly. Then it silently queries a remote large language model, an LLM, and essentially asks, given this exact configuration, write me a script to bypass it.
Oh, wow. So it's asking for a custom key.
Yes. The remote LLM generates a completely unique execution string, a tailored exploit, and sends it back. It generates the weaponized code on the fly.
Here's where it gets really interesting, though, because that code is generated on the spot, traditional hash-based signatures, which is how, 90% of antivirus programs historically caught bad files.
At least 90%, yeah.
They are 100% ineffective now.
Mhm.
Every single infection is a zero-day event because the code literally did not exist before that exact second.
Exactly. It makes them effectively invisible to traditional tools. The data from late 2025 showed that 82% of successful detections were completely malware-free.
Malware-free malware. That's wild.
Right. The attackers weren't dropping malicious files at all. They were using valid credentials and AI-generated commands that blended perfectly into normal, everyday administrative traffic.
So we know human speed is way too slow to catch these AI attacks. And we know they're practically invisible because they shapeshift. That brings up a massive question for anyone running a business right now.
What are they after?
Exactly. What exactly are these hyperfast machines trying to steal? Because if you think it's just your customer credit card data, you are missing the bigger picture here.
You really are. It's not just about data anymore.
We are seeing the total industrialization of compute theft. It's this new black market called LLM jacking.
Yes. Hackers don't just want your internal files, they want your cloud compute budget.
Which is wildly expensive right now.
Insanely expensive. So they are specifically targeting unsecured cloud environments like AWS Bedrock or Azure OpenAI to harvest your API keys. And once they have access, they aren't exfiltrating your data. They're quietly using your high-performance GPU clusters to run their own massive AI inference tasks.
So your company is unwittingly subsidizing global criminal AI operations.
Pretty much.
I mean, if you're a startup running a new app on AWS, you might not even notice you've been breached until you wake up to an invoice and realize you're on the hook for like $50,000 of criminal AI compute.
And by then, the damage is totally done.
iclek's paper details Operation Bazaar from January 2026. Decentralized syndicates were using a specialized Discord bot to literally resell these hijacked compute cycles to other criminals.
It's an entire underground economy.
Yeah. And they did it by targeting vulnerable model context protocol, or MCP, endpoints.
Yeah.
Walk us through how that actually works.
Well, MCP endpoints are fascinating because they act as the bridge between an LLM and local data.
Okay.
So if your company uses an AI assistant to search internal documents, it uses an MCP endpoint to fetch that data. The problem is, companies frequently treat these endpoints as internal tools, right? They lack the rigorous identity and access management protocols they apply to their public-facing databases.
This is the soft underbelly of the enterprise.
Exactly. And you can't catch an attacker abusing this with a traditional web firewall because the queries the attacker is sending aren't inherently malicious.
Because they aren't like injecting SQL code or something.
Right. They are just sending massive amounts of math to be processed.
So if the traffic looks completely normal, just heavy, how do you catch it before your cloud bill bankrupts you?
Defenders have to look for massive token per second, or TPS, spikes. The primary mathematical indicator of a hijack session is if a specific API key suddenly jumps 400% in volume compared to its 30-day baseline.
Oh, so it's a purely volumetric detection.
Entirely volumetric, yeah.
And this compute theft is being carried out by agentic malware, right? The self-driving threat. The hackers give the AI a high-level goal, like locate and exfiltrate the Q3 2026 internal financial audit, and then they just let it loose to figure it out.
Yes, goal-oriented autonomy.
But wait, I have to push back on this a little bit. Let's say this AI agent is wandering around my network, and it hits an internal firewall. Doesn't it just keep hammering the door trying to brute force its way in?
That's what you would expect, right?
Yeah, because a machine doing that 1,000 times a second is going to trip every alarm I have.
But that is exactly how older deterministic malware worked, and it's why it was so noisy and easy to catch. Agentic malware possesses a recursive reasoning engine.
Meaning it actually thinks about the roadblock.
Exactly. If it hits a blocked port, it does not hammer it. It stops, it sits quietly in the machine's memory, and it starts scanning your company's internal documentation.
Wait, really?
Yes. It reads your wiki pages. It reads your cached Slack messages. It figures out an alternative lateral movement path based on your own employees' chatter.
Hold on. Corporate Slack is a total mess. It's acronyms, inside jokes, broken sentences. How does an external piece of malware parse our internal jargon and figure out a network topology from that?
Because the malware is backed by an LLM, and LLMs are specifically trained on unstructured, messy human dialogue, it can deduce context.
Oh, man, of course it can.
So if it reads a message from an engineer saying, hey, I had to open port 8080 on the legacy dev server to push the Q3 build, the malware's reasoning engine understands that legacy dev server is a secondary target and port 8080 is an open door.
That is wild. It maps your network using your own conversations.
Yes. And because it reasons this out locally, it completely eliminates the noisy command and control chatter that security teams used to rely on for detection. It doesn't need to phone home for instructions.
So it's basically silent.
The 2025 data noted that these self-driving threats reduce their detection footprint by 60% simply because they stay entirely resident in memory while they quietly think their way through your network.
That is genuinely terrifying. So if the malware is practically invisible, if it shapeshifts to avoid signature alarms, and if it's reading our internal wikis to avoid making noise, how on earth do we actually detect it?
It's a huge challenge.
Yeah, I mean, if we can't look for known bad code, what is the strategy? iclek argues we have to shift entirely to looking for malicious intent through mathematical anomalies. And this brings up the concept of synthetic perfection.
This is one of the most elegant pieces of analysis in the research, actually.
Yeah, I loved it, this part.
Right, because when an AI agent moves through your network, it tries to mimic human behavior. It types, it clicks, it browses, but it fundamentally fails to replicate the biological inconsistency of a real human being.
Because humans are messy.
Exactly. Human interaction has a specific rhythmic signature full of nonlinear delays. AI-generated traffic, even when the attacker explicitly programs it to add random delays or jitter, exhibits a mathematical perfection underneath it all.
So what does this all mean for the listener? It's like trying to spot a highly advanced robot walking through a crowded street. You don't look at their face to see if they're a robot, you look at their footsteps.
That's a great way to put it.
Because humans stumble, we pause to look at a bird, our stride length varies slightly. The machine's rhythm, even if it tries to fake a stumble, averages out to something mathematically perfect.
Exactly. It's like a heartbeat monitor. A human heartbeat naturally speeds up and slows down slightly with breathing. A machine trying to fake a heartbeat makes the spacing just too perfect.
And to spot that perfect spacing in network traffic, analysts are now using fast Fourier transforms, or FFT.
Right.
Okay, unpack FST for us. How does a math equation translate to catching a hacker?
So FFT is a mathematical algorithm that converts the timing data of network packets from the time domain into the frequency domain.
Okay, I'm with you.
Instead of looking at a timeline of when packets arrive, you look for the underlying frequencies of those arrivals. iclek cites a Darktrace study from 2025 showing that AI beacons, because they lack biological randomness, produce a highly distinct spectral spike, a perfect harmonic frequency that human users simply never create.
Wow.
It sticks out like a sore thumb on a frequency chart.
So we aren't catching them with rules anymore. We are catching them with pure math.
Precisely. And that mathematical approach scales up to what the paper calls the new gold standard of detection. Unsupervised learning via isolation forests.
Isolation forests, okay.
In 2026, we have to abandon the idea that we can define what bad looks like ahead of time. The attacks are too unique. Instead, we have to look for what is statistically isolated from the normal baseline of your specific company.
Instead of looking for a needle in a haystack, you're just looking for the piece of hay that doesn't belong.
Right.
So how does the isolation forest actually do that?
It tracks highly specific features of every action. For example, it tracks time delta, which is the microsecond gap between API requests.
Okay, timing.
It tracks request complexity, which measures the depth of nested calls, and it measures resource rarity, which looks at how obscure the internal files being accessed are.
Got it. So it's looking at all these dimensions at once.
Exactly. If a user account suddenly accesses a deeply buried financial file using a highly complex API call with mathematically perfect microsecond timing, that event becomes plotted mathematically far away from the rest of the company's normal behavior.
It is isolated in the forest.
Exactly. Sentinel alone noted that using this exact unsupervised learning method resulted in a 42% reduction in discovery time for fileless AI native malware.
Okay, so we have the math. We have the isolation forest spotting the perfect footprints.
Hmm.
But let's go back to that velocity crisis from the very beginning.
The 27 seconds.
Right. Even if the math spots the anomaly, a human being cannot run an isolation forest algorithm, verify the alert, and physically shut down a compromised server in 27 seconds.
No, it's impossible.
We need AI to defend against the AI, which brings up a very human concern. If we let an autonomous AI defend the network, what stops it from getting spooked by a weird login and just locking the CEO out of a critical board meeting?
That is the exact fear that has held the entire industry back for years.
Because no one wants to be the IT guy who blocked the CEO.
Exactly. iclek points out that 72% of security leaders intentionally delayed deploying autonomous AI defenses because of the fear of false positives. They were terrified of friendly fire business disruption.
Makes sense.
Because if an AI defense optimizes purely for security, its easiest move is just to shut everything down the moment it looks weird, totally destroying the availability of the network for actual employees.
Right, so if the AI is making decisions on the fly, it can't just be a binary kill switch. It has to have levels of certainty before it isolates a CEO.
Yeah.
How does the Agentic SOC, the Security Operations Center of 2026, solve this?
Through a framework called Guarded Autonomy. It uses a multi-tiered confidence threshold system driven by Bayesian inference.
Bayesian inference, okay.
Which simply means the AI constantly updates its probability that an attack is happening every time it sees a new piece of evidence. It doesn't just react, it assigns a mathematical probability score to every single alert.
So it's constantly weighing the odds.
Yes, allowing the defense to scale its response dynamically based on how certain it is.
So let's look at how these thresholds actually play out in a real environment. The lowest tier is the advisory zone for events with less than 80% confidence. What happens there?
In the advisory zone, the AI sees something weird, maybe an employee logging in from a new device, but it isn't sure it's malicious, so it alerts a human.
But not just with a messy log file, right?
No, instead of sending a raw, cryptic log, the AI builds a complete pre-incident dossier in plain English. It explains the context, the user history, and exactly why it flagged it.
That's super helpful.
It is. This alone reduced alert fatigue by 65% because it stops human analysts from chasing ghosts and doing all those manual lookups.
But if the AI gathers more evidence and hits tier 2, the validation zone, which is 80 to 95% confident, it stops waiting for a human, right?
Correct. Here, the AI takes action, but it's passive containment.
Like what?
If it sees a rare command tied to an unusual IP address, it might silently increase the multi-factor authentication requirements for that specific user, forcing a prompt on their phone.
Just to double check.
Exactly. Or, brilliantly, it might seamlessly route the attacker's traffic into a dynamic honeypot, a fake replica of the network. It observes the threat without breaking the actual business process.
And then you have the heavy hitter, tier 3, the autonomous strike zone. Greater than 95% confidence.
At 95% certainty, the mathematical probability of an attack is near certain, and human intervention is simply too slow.
So it just acts.
In milliseconds, the AI automatically isolates the infected host from the network, revokes all identity tokens, and takes a memory snapshot for forensics.
There's an incredible real-world case study in the paper about this from a mid-sized financial firm in 2025 that proves how crucial this is.
Oh, yes, the CEO example.
Yeah. An AI-native adversary tried a highly stealthy data exfiltration. The defensive AI watched the behavior, updated its Bayesian probability, and within 14 seconds of the initial lateral movement, it hit a 97% confidence score.
14 seconds.
It instantly revoked the compromised accounts token before it could touch the core database. But, and this is why Guarded Autonomy is genius, at that exact same time, the CEO of the firm was traveling and had a minor login anomaly on a new Wi-Fi network.
Right, which normally might trigger a block.
Exactly. But the system scored the CEO's anomaly at only 45% confidence.
Oh.
So the CEO was left completely untouched. The AI perfectly distinguished between an executive doing something slightly weird and true, mathematically certain malicious intent.
It's incredible.
And IBM notes that this kind of autonomous containment saves companies an average of $2.1 million per breach.
It's a massive financial and operational advantage, but as you might imagine, handing the keys over to an autonomous system completely redefines what a human being actually does in a security center.
Exactly. With machines, fighting machines at millimeter speeds, where does that leave you, the human being listening to this deep dive? If the machine is doing the blocking, what is your job?
The human element is still vital, just different.
Right, because iclek says the era of screen watching is over. We are moving to the Centaur SOC.
A centaur, referring to the synergy of human and machine working together. Analysts are transitioning from being hunters who manually piece together logs to being architects.
Makes sense.
You are no longer expected to manually triage thousands of flashing red alerts on a dashboard. The machine handles the tactical knife fight. The human handles the grand strategy.
The paper outlines two totally new human roles that I think will define IT careers for the next decade. First, the model auditor.
Yes.
Your entire job is to audit the AI's decision-making process. You ensure those confidence thresholds are calibrated correctly, and you prevent model drift, which is when an AI slowly learns bad habits over time because the network environment changes.
It's basically AI psychology.
Totally. And second, the threat strategist. You aren't hunting the individual hacker's code anymore. You are hunting the underlying logic and intent of the adversary.
Right. While the attacker's AI generates polymorphic shape-shifting code, the human strategist is analyzing the high-level campaign.
Looking at the big picture.
Exactly. They are asking, is this weird burst of traffic on our public server just a diversion to mask a stealthy LLM jacking attempt on our internal cloud? It's a higher level of chess. And it works. PwC noted a 40% increase in proactive threat discovery when human analysts were finally freed from the noise floor of daily alerts and allowed to focus on actual strategy.
Okay, we've covered the velocity crisis, self-driving malware, catching math with math, and the Centaur SOC. But iclek doesn't stop at 2026. Where is this arms race going next?
If we connect this to the bigger picture, as we move into 2027 and beyond, we are facing the convergence of quantum computing and generative AI.
Two massive buzzwords colliding.
Exactly. The paper refers to this new hyperfast environment as cyberspace, where traditional encryption might be mathematically bypassed in seconds.
Wait, if encryption fails, how do you defend a network?
Through what iclek calls agentic resilience, the networks of the near future won't just defend themselves. They will exhibit biological self-healing properties.
Self-healing networks.
Yes. Imagine a network that detects an AI intruder and instantly automatically reconfigures its own topology. It shifts its own layout into a virtual labyrinth of ghost subnets to track the attacker.
Wow.
Yeah, it's constantly moving the target, so the attacker's LLM can never accurately map the environment. It is a living, breathing, digital organism.
It's incredible to think about. The core lesson here for you, the listener, is right there in the author's sign-off. Master the data, and you master the fight.
Exactly.
The invisible is only a threat to those who refuse to see the new digital reality. The days of Ethan's security are completely gone, replaced by fluid reasoning machines.
It is a remarkable evolution in technology, but, this raises an important question, one that I think builds on everything we've discussed today.
What's that?
Well, the text mentions automated threat intelligence sharing, where defensive networks share their mathematical logic globally in milliseconds to immunize the whole ecosystem. But if these networks eventually become fully self-healing, constantly shifting their own topologies at quantum speeds to trap AI intruders, do we inevitably reach a point where human IT teams are completely locked out of their own infrastructure's logic?
Oh, wow.
Will we be forced to blindly trust an AI that has evolved so fast and created such complex ghost subnets that it can no longer even explain its mathematically perfect decisions to a human brain?
That is a chilling thought to end on. If the defense becomes too complex for the creators to understand, who is really in control of the network? Thank you for joining us on this deep dive into the invisible wars happening inside our networks right now. Keep your eyes open, stay curious, and keep questioning the digital world around you. We'll catch you next time.